Welcome to the 8th episode of our series, where we will be discussing the fascinating world of deep learning and neural networks. In this episode, we will provide an introduction to deep learning and how neural networks work, explore the advancements in deep learning, and showcase some of the real-world applications of this technology. We will also discuss the future of deep learning and neural networks, the challenges facing this field, and the ethical considerations that need to be addressed. Finally, we will provide a summary of our discussion and key takeaways. So, deep learning is a subset of machine learning, a field of artificial intelligence that involves training algorithms to learn from data. Unlike traditional machine learning algorithms, deep learning algorithms use multiple layers of artificial neural networks to learn and extract features from the data. Neural networks are an essential component of deep learning and are designed to mimic the functionality of the human brain. They are made up of interconnected nodes, also called artificial neurons, which receive and process information. The nodes are arranged in layers, including the input layer, one or more hidden layers, and the output layer. Information flows from the input layer through the hidden layers, where the information is processed and transformed to the output layer, where the final result is produced. Each node performs a simple mathematical function on the information it receives, and the output of each node is used as the input for the next layer. During training, the network adjusts the weights between nodes to optimize its performance, making the neural network increasingly effective at processing and analyzing complex data sets. With the rise of deep learning, neural networks have become increasingly important in a wide range of applications, from image and speech recognition to natural language processing and autonomous vehicles. Despite their effectiveness, neural networks have their limitations, and research is ongoing to overcome these limitations and to make them even more powerful and versatile. Deep learning has made significant advancements in recent years, which has revolutionized various industries. One of the major advancements in deep learning is the ability to solve complex problems that were previously considered impossible to tackle. Deep learning has proven to be extremely effective in image and speech recognition, natural language processing, and robotics. The availability of massive amounts of data and high computing power has made it possible to train neural networks with millions of parameters, resulting in models that can make highly accurate predictions. Furthermore, the use of convolutional neural networks (CNNs) has allowed for the creation of deep learning models that can analyze images and videos with human-like accuracy. Another advancement in deep learning is the use of recurrent neural networks (RNNs) for natural language processing. RNNs can process sequences of words, and this has enabled the development of chatbots and virtual assistants that can understand and respond to human language. In addition, reinforcement learning, a type of deep learning, has been used to train robots to perform complex tasks, such as playing games or navigating through a physical environment. These advancements have made it possible to solve real-world problems in various fields, including healthcare, finance, and transportation. Deep learning has proven to be a powerful tool in various real-world applications. In healthcare, deep learning has been applied to various tasks such as medical image analysis, drug discovery, and patient diagnosis and monitoring. For example, deep learning models have been trained to detect early signs of diseases, such as cancer, by analyzing medical images. In finance, deep learning is used for fraud detection, risk analysis, and investment prediction. Deep learning algorithms can analyze vast amounts of financial data and identify fraudulent transactions or predict future market trends. In the manufacturing industry, deep learning is used for predictive maintenance, quality control, and process optimization. By analyzing sensor data from equipment and production lines, deep learning models can predict when maintenance is needed, detect defects in products, and optimize production processes. Overall, deep learning has the potential to transform various industries by improving efficiency, reducing costs, and enabling new capabilities. The future of deep learning and neural networks is highly anticipated due to the potential for further advancements and applications. As researchers continue to make breakthroughs in deep learning, we can expect to see improvements in areas such as accuracy, performance, and scalability. Additionally, the development of novel deep learning architectures and algorithms is expected to push the boundaries of what is currently possible. The future of deep learning is also heavily influenced by the growth of big data, the Internet of Things (IoT), and edge computing. The increasing amounts of data generated by these technologies present new opportunities and challenges for deep learning. Moreover, the combination of deep learning with IoT and edge computing can lead to the development of more intelligent and efficient systems. Another area that will likely see significant growth in the future is the use of deep learning in robotics and autonomous systems. With the development of more advanced and sophisticated robots, the use of deep learning algorithms for perception, planning, and decision-making will become increasingly important. This will enable robots to perform complex tasks in unstructured environments, such as manufacturing, agriculture, and healthcare. As deep learning and neural networks continue to advance, it will be important to ensure that they are developed and deployed responsibly and ethically. This includes addressing issues of bias, transparency, and accountability, and ensuring that the benefits of deep learning are shared widely and equitably. In order to overcome the challenge of labeled data, researchers are exploring various techniques such as transfer learning, which allows models to be trained on a smaller dataset and then fine-tuned for a specific task. Other techniques include active learning, which uses human input to label the most informative data points, and semi-supervised learning, which uses both labeled and unlabeled data to train models. Interpretability and transparency are also important issues in deep learning. This is because deep learning models can often be seen as black boxes, making it difficult to understand how they arrived at a particular decision or prediction. However, recent research has focused on developing methods to interpret deep learning models, such as generating heat maps to show which parts of an image are most important for a particular classification, or generating natural language explanations of model predictions. These approaches are important to build trust in deep learning models and to ensure that they are being used in a responsible and ethical manner. One of the main ethical considerations with deep learning is the potential for bias in the data used to train the models. If the training data is not representative of the entire population or contains biases, the resulting model may perpetuate those biases, leading to unfair or discriminatory outcomes. This is especially concerning in applications such as hiring, lending, and law enforcement, where biased models could result in systemic discrimination. Another ethical consideration with deep learning is the potential for privacy violations. Deep learning models often require access to large amounts of personal data to function, which can put individuals' privacy at risk. It is essential to ensure that the data is collected and used in a way that respects individuals' privacy rights and is compliant with relevant regulations. Additionally, deep learning models can be vulnerable to attacks, which can result in security breaches and compromised data. It is crucial to develop secure models and ensure that appropriate safeguards are in place to protect sensitive data. Overall, it is crucial to ensure that ethical considerations are at the forefront of deep learning development and deployment to avoid unintended negative consequences. This involves transparent and accountable development processes, the use of representative and unbiased data, and the implementation of appropriate privacy and security measures. In conclusion, deep learning and neural networks have the potential to transform various industries and solve some of the world's most complex problems. While there are still challenges and ethical considerations that need to be addressed, the future of deep learning looks bright. By continuing to advance the technology in a responsible and ethical manner, we can unlock its full potential and make a positive impact on society.